Some of you noticed that yesterday we also touched on method overloading. And yes, that was intentional. While the main focus of the lesson was inheritance and method overriding, I added overloading so that you can clearly see the difference between the two. Welcome back to day 13 of Java in 30 days by Quipoin. Today, we are diving into one of the core pillars of object-oriented programming, that is polymorphism. Polymorphism simply means one thing, many forms. In Java, this can be achieved in two ways. Compile time polymorphism, also called method overloading, and runtime polymorphism, also called method overriding. Let's see both in action with example. First, let's create a base class. So we will write class shape and then we will write void draw. Then we will end this and we will print our statement. And then inside parenthesis we will write drawing a shape. And we will end this with semicolon. Then we will create a subclass. So we will write class circle class circle extends keyword. Then we will write our shape and we will override. So we will write void draw and then similar to the previous one we will write and print system dot out dot print ln and then in parenthesis we will write drawing a circle. And we will end this and again we will create a subclass for rectangle. So we will write class rectangle extends and then we will write shape and then curly braces. Again we will override and we will write void draw and then parenthesis and curly braces and we will print our statement. And then we will write inside parenthesis drawing a rectangle. And then we will put semicolon. Then we will create a compile time polymorphism demonstration. So we will write class calculator and then we will put curly braces and we will do method overloading. So we will write int add inside parenthesis we will write int a comma int b. Then we will end this with curly braces and we will write return a plus b and then we will put semicolon. Then we will do for double. So we will write double add and then inside parenthesis we will write double A comma double B, and then like the previous one we will return A plus B, and then we will take another, so we will write one more for int add, and then we will pass three parameters, int A comma int B comma int C, and then we will put curly braces, and we will return all the three by writing return A plus B plus C, and then semicolon. Now we will go to our main polymorphism class, and then here we will write shape S1 is equal to new circle, and then we will end this. This is reference of the parent object of a child, and we are doing here runtime polymorphism. Similarly, for the shape S2 we will write new rectangle, and then we will pass and we will call S1 dot draw, and then similarly we will call for S2 dot draw, and we will end, and then we will compile it. So we will write calculator calc is equal to new calculator, and then we will write our print statement. So system dot out dot print ln, and inside parenthesis we will pass sum of two ends, and then we will write our plus sign with calc dot add, and then we will pass 5 and here 10, and similarly let's copy paste, and we will go for some more print statement, and then we will pass for two doubles, so we will change here to doubles, and then let's take here 3.5 and let's make it here 4.5, and then we will go for our next statement, and we will here print sum of three ends, and we will let pass it with 1 comma 2 comma 3, and now our code looks complete. So let's save, and then right click, run as Java application, proceed, and you can see the output. Now what's happening here is the runtime polymorphism, as it is known, it is method overriding. So the class shape has a method draw. Both circle and rectangle overrides this method with their own implementation. When we call, let me show you. Let's drag it down. When we call s1.draw, it checks the object type circle at the runtime and executes that method. Same with s2.draw, which executes rectangle version. And then this is called dynamic method dispatch. Similarly, for compile time, the calculator class has multiple add method with different parameters. And at compile time, Java decides which version of add to call based on the arguments. And so that's polymorphism, the power to perform a single action in multiple ways. Overloading happens at compile time. Overriding happens at runtime. This is what makes Java so flexible and powerful in object oriented programming. In the next session, we will learn about abstraction, that is, hiding details and showing only useful essential features. So let's meet on day 14.